Assalamu alaikum wa rahmatullahi wa barakatuhu. Welcome students for the next session of chemistry class. Today we will be talking about Mendeleev's periodic classification. See, in last class we had learned about Newland's octaves. So what was the difference between these two? Newland classified the elements and he gave octaves law. How did he classify? He classified based on the similarities, that is similar chemical properties, right? Mendeleev, who is a Russian scientist, in 1869, he put forth his periodic table, tried to arrange the known elements in the order of relative atomic masses based on their properties, similarities. What was actual criteria of classification? He took both physical and chemical properties of elements and tried to arrange the similar elements as columns. Okay. Then next, he also did arrange the elements based on atomic masses. Took the smallest atomic mass and keep on arranging as per the order. That means from the smallest to highest atomic order. What was the difference between the other scientists and Mendeleev? So here the difference is Mendeleev tried to arrange the elements based on similarities and differences. Yes, then it also tried to arrange the elements based on relative atomic masses. So he created 8 groups, okay, and placed the similar elements in the groups. So when you look at these groups, you can see that below hydrogen, lithium, sodium, potassium, all these elements, they showed similar properties, hence they are formed as one column. Okay. Similarly, if you go to the next group, you can see this beryllium, magnesium, calcium form the next group. Now he also said that the properties of elements or the periodic function of their atomic masses, that means the similarities exist or these similarities are repeating. It is periodic in nature. Regularly there are properties which keep on repeating. Okay. Now when he did that, there is something, if you can look at the table. So we find, what are these? These are nothing but the gaps, the empty spaces that were left after arranging the elements. So instead of just looking this as a defect or a problem, what he did, he boldly predicted that there are elements, means they do exist elements which we have not yet discovered. So these properties, they keep on repeating. These are regular properties we find at regular intervals. Therefore, he put forward the law known as Mendeleev's periodic law, which states that the properties of elements are periodic function of their atomic masses. He had also predicted that there are elements which could be discovered later. So the main thing what he did was not only predict the elements which can be discovered later, but he was also able to work out their atomic masses. So after that, he said that the missing elements will be having this atomic masses, hence based on the position he was able to predict the properties of those elements. So this periodic table of Mendeleev's was very helpful in predicting the further elements which were discovered. Okay, for example, whatever the gaps which are present in the Mendeleev's period, after his discovery, many scientists who could discover the elements. So those elements which you can see as springs, these are the elements which were predicted by Mendeleev and it was later discovered and they could fit easily. So not only that, even the properties which he predicted were very close to it. And this, the one what is being given placed here, it was easily able to fit in the periodic table without changing the existing elements which were present. Moreover that, he did not only fix to the atomic masses, sometimes it so happened that when the properties were similar, he tried to arrange those elements without looking for the atomic masses. Even though the atomic masses did not increase accordingly, he still was able to place them based on the similarities. So this was a positive or a plus point that gave an edge for his classification. For example, so you can see here cobalt and nickel. So these are the elements, cobalt and nickel. See, cobalt and nickel, if you compare, they are having different atomic masses. Cobalt is having a higher atomic mass compared to nickel, but it was placed before cobalt. Swapping the order of elements in order to fit their properties better. So Mendeleev later, when he said that there are some elements that existed, for example, below the aluminium there was a gap in Mendeleev's periodic table. So he predicted that 2 more elements can fit below aluminium having the same property as that of this entire group 3. So it was found to be true. Scientists who discovered that. So this was one of the major contribution for the Mendeleev's periodic table. He is rightly called as the father of periodic table. Not even that, even the discovery of this noble gases which were least reactive, inert and found in very low concentration. Even these gases could find the place in the Mendeleev's periodic table without disturbing the existing trend. So if you can see this lighter shade color, lithium, sodium and potassium, what are these? They are Dobereiner's triads. So even Dobereiner's triad could find the place in Mendeleev's periodic table. So whatever you see in the blue are the elements that are known before, colored things are those that are discovered later. Now let us see what are the drawbacks of Mendeleev's. So what are the drawbacks? Can you guess the drawbacks of Mendeleev's? So these are the limitations. First is the position of hydrogen. Now hydrogen had both the properties of metal and non-metals. This hydrogen did not find place in Mendeleev's proper place in Mendeleev's periodic table. Second is anomalous pairs of elements. For example, cobalt and nickel, where cobalt is having higher atomic mass compared to nickel was placed before nickel. Discovery of isotopes. So you know what are isotopes? Those are the elements having similar chemical properties but different atomic masses. They did not find place in Mendeleev's periodic table. Dissimilar elements were placed together. For example, lithium, sodium and potassium were placed with copper and gold in group. Okay. Now similar elements like copper, mercury and silicon were placed in different groups. So dissimilar elements were placed in the one group. Mosley in 1913, he was the one who took the actual credit from Mendeleev's periodic table, and he said that instead of arranging the elements based on atomic masses, if it was arranged based on atomic number, whatever the limitations of Mendeleev were there, it could be eliminated. So this was the blueprint for the development of modern periodic table. Modern periodic table will have 18 groups and 7 periods. So this you will be studying in the next session. Hope you have understood. Thank you very much for watching this.